Hello, welcome back, Ling statisticians, for the second round of our first batch of R commands, or at least an explanation of how to use those R commands. I've got the commands loaded up here on this little web page here that you can access through the course website, but I've also got the home page for the course website loaded up here because we're going to look at one of the data sets, or at least the first data set in this video today. So you can, we're going to load it into R and play around with it a bit. So if you follow this datasets link on the course homepage, this will look a little bit different again when you see it by the time fall rolls around. But the first data set is the class VOT measures from 2011, from 10 years ago. So your first homework assignment is to measure your own VOT in a variety of different words, which are listed here. But if you click on this link, you get this text file. You can see the actual file name up here. So this is already organized for us so that we can play around with it with ease. One of your jobs for your homework, I guess you could say, your homework jobs, is that you are going to have to organize your own data set in the appropriate way so you can load it up into R as well. And I'm going to walk you through how to do that a bit today, just because that's kind of where all statistical analysis starts with R. So anyways, without any further ado, maybe we can get into it. But I've got this data set here. It's a text file that's loaded up on my website, but I also have it on my hard drive here for this particular computer. It's the way I format it is with a using Excel. Or, you can do it with any spreadsheet program that you prefer. I'm going to make this a little bit bigger so you can see it better. It all matches up. It's the same thing. But I use Excel, but you have to format it in very specific ways for R to be able to read it. So I'm going to walk you through the details of that by the time we're done with this video. All right, so what we're trying to create here or analyze is what's called a data frame. So it's data that's not just, 12 numbers of like P's and P pods. It's more than that. It's data that can include more than a few items and can have more than one sort of variable changing for any specific observation that we're working with. So if you have data like that, you're going to have to format it properly. And this turns out to be an unexpectedly big challenge working with R. And in fact, I'd say it's maybe the least fun thing about working with R, but once you get the hang of it, you kind of know what to expect and you just kind of forget about it. But for beginning students, it's a real pain in the neck. All right, so the basic structure for data in R is called a data frame. And a data frame is basically a table with rows and columns, just like what we see here in this Excel spreadsheet or in this text file that you can access through the website. So each row in a data frame contains a different observation. So just to go back to this specific example, these are different students from the class 10 years ago. This first line or first row in the data frame or data set gives you headers for each column. So it tells you what each column represents for each observation. But then beyond that, each one of these rows is a different observation. So for the first row, which is row number 2 in the spreadsheet, first observation row, I guess you could say, it's Zilka is the speaker, Peel is the word she said, P is the stop at the beginning, E is the vowel. It's a bilabial stop. It's an aspirated bilabial stop. And then kind of the crucial point here is that her VOT in this case was 104 milliseconds. So this is the number that's going to vary, but then it can potentially vary with all these different variables here listed in the columns that come before the VOT. There are other stats programs out there which I'm not going to work with for this class, but they organize the numbers in an entirely different way, where instead of, having different observations for rows, you might have different observations for columns, that sort of thing. We have to organize it, or highly recommend that you organize your data in this fashion because it's the way that's going to work the best when you use R. Again, a few minutes in, for some reason, my voice just starts to give way. Anyways, each row in the data frame contains a different observation. And the columns in each row contain the values of different variables like word, stop, vowel, so on and so forth. So the easiest way to load a data frame into R is to first create it in Excel, or if you have some other spreadsheet program which does similar things, you can use those, or that spreadsheet program. But there are a lot of things that can go wrong when you do this. So because R is really persnickety about how the data file should be formatted. So I'm going to walk you through not only how you should do it, but also what could possibly go wrong. All right, so I've already walked kind of through the basics here, but we have this spreadsheet full of data over here, and we want to load it into R. So it's got the same name. It's labeled class VOT here. It's a text file, which is why this looks like kind of just plain text, this little icon in Excel rather than an Excel spreadsheet icon with like the little X in it. And then it's the same thing on here. Here, the .txt extension is explicit, so you don't have to guess about that. Anyways, the first row here's a few important observations about how you have to format this. So the first row in each column has to have a unique name. So these are all the variable names basically for all the different observations we'll see below the first row. And so each one of these words here in row 1 has to be unique. I can't have like 2 different speaker columns, right? Or 2 different like word columns or what have you. And so this is a mistake that people will sort of often make, is like, you know, they're looking at Zilka or like one particular speaker, and they have that speaker like produce a token like more than once. So let's say we had a different sort of world where Zilka produced Peel like twice or maybe even 3 times. And the second time she had 118 milliseconds or something like that. People tend to be tempted to just kind of like say, put another column of VOT here and just say, well, she had produced Peel twice, and the first time it was 104 milliseconds and the second time it was 118 milliseconds. Like, this will screw R up. R is not expecting data to be formatted in that fashion, so you can't do it that way. If you have a different observation for every single token that you've made an observation for that you got data from, you have to have a separate row in this data frame format. So get rid of this. Don't have multiple VOT columns. Each one has to be unique. There can also be no spaces in the column headers. So none of these are really appropriate for spaces here. But you couldn't have something like voice space onset space time. If you do that, as soon as R sees a space, even though you don't actually see it, as soon as it sees that gap between words, then it's going to complain. And it's going to say, I can't read your data. So call VOT. Also, we're going to get into Z-scores in the next lecture, but say, you know, you can't have a Z space score. It's got to be Z dash score, or maybe Z underline score, something like that. You have to have everything connected all the way through. And you can also similarly name columns like speaker 1 or speaker 2, or like stop 1, stop 2, so on and so forth, as long as there's no spaces in it. There can also be no empty cells in the data frame. So let's say, oh, you know, when Zilka said poll, she forgot to like actually measure that VOT for that production. You can't just like leave this blank and expect R to be able to read it. This is perhaps the dumbest thing about R's data reading capabilities, because you can have like a data file with like thousands and thousands of lines, which is typical, I guess, for like thesis size projects. And then if you're just missing one like data point, it's like, oh, I can't read anything. But if you have a blank like this, you can say put NA in there, and then it won't complain about that. So you don't have to have specific values for everything. You don't have to like fill it in as if you're just like making stuff up, which you shouldn't do either, by the way. Never make up data. Otherwise, we're just wasting our time. But if you don't have that data point, just put NA rather than a blank, because otherwise it's not going to work. And so the way save this in Excel is you say save it as, and I've got data sets here for this year's version of the class. And crucially, you don't save it as an Excel workbook of any sort. You save it as tab delimited text. And another option, which I'll mention, is CSV, which a lot of people use, which will put the data in comma delimited format. So if you look at it, it looks like just, you know, Zilka comma, tail comma, T comma, so on and so forth. Tab delimited text is what I like to work with. So that has the data with like Zilka tab, tail tab, T tab, so on and so forth.
but that will determine how R can read the data once you are ready to work with it in the system. And this also gives it that .txt extension at the end of the file name. Yeah, so I've already saved it, so I'm not going to save it again, but that's how you would do that. And now we want to look at how to read in the data file into R once we're ready to work with it. And again, this is going to be a little bit different for Mac versus PC. So I'm going to show you how to do it on your own machine. I post these data sets to the website, so there's a way to read it directly through the website, which we've seen before, but it's also going to be helpful for you to be able to read this on your own machine in many different instances. So the way to do that on a Mac, let me make this smaller. And let us see the cursor there. So go to MISC in the menu options at the top of the window and go to Change Working Directory. And then you just pick which directory you're going to play around with here. So I'm going to go to this year's version of the class and the data sets. And this is that file that I have saved that we were just looking at. But I can't open it directly like this because R wants you to always type in a command of some sort. So this is the kind of nice and easy part of it. You just say open when you get to the directory you like or the directory that has the data you want in it. And apparently on a PC, you can do this by selecting Change Directory or Change DIR. And then under the File tab in the main R menu, I'll let you guys sort that out yourself. What I'm going to do is show you the command you can type in here to get that data into the R console. And I'm going to copy and paste it. It looks like this. So the main thrust of this is that it's a read.table command. And then within these parentheses, I have the file name itself in quotes, and then comma, header equals T. And that header equals T bit just means that this first row is giving me the headers for each column. That is the variable names for the different columns. And so like we've seen before, this is the command we're using. It has these different arguments or parameters. Crucially, the file name, which is in that directory that I selected in this header equals T parameter as well. And then this just says pipe it into this data frame in the R console, this VOT data frame. So I'll hit return here. And that worked. If it didn't work, it would have complained about something. Actually, maybe I'll show you what happens when it does not like what it sees. Maybe I'll just delete this data point here, and I'll save this as class VOT2, like this. Still as a tab delimited text file. And it's going to say that thing, and don't worry about that. That's just an Excel thing. Excel wants you to use everything in Excel format for proprietary reasons, because how else are they going to make money? Anyways, let's try to read this guy in and call it VOT data 2. And I do that, and it says, oh, look out, line 2 did not have 7 elements. And what it means by line 2 is right here. So it has 1, 2, 3, 4, 5, 6, and it gets to 7, then it's blank. And it's like, oh, I don't know what to do with that. So I can't read in that data. That's what will happen if you have your data formatted like that. And the way to fix it is just fill it in with either NA or the actual data point. Okay, so there's other commands like read.csv. That's the command you use if you did save your file as a comma separated value format, CSV format. Read.table is what you use for these tab delimited text files. And that's just a matter of choice. So I'm going to choose to use the .text format. And we're going to roll from there. And I think I've already said everything I need to say here. There's other data frames. Sorry, do we remember what this was? No, let's open up the original. There's other data files that you might see in the textbook, which are formatted in a slightly different way. So in addition to having different variable names for the headers here, there's like a unique ID identifier in the first column, and then each one of these rows has a different number. And I'll show you a little trick in case you don't know how to do this, but if you highlight this column in Excel and then just grab this little square at the corner of your highlighted section, you can drag all the numbers down, and it will sort of just automatically itemize the different rows for you, which is nice. It's nice so you don't have to like type in all those numbers or anything like that. Anyways, this is another way that people can format this data in R or for R. And I think I have a point here about, yeah, there's another argument you can use, row.names equals 1. And if it does that, then it's expecting, if you put that in that read command, then it will expect all of these ID numbers to be unique as well. That to me is a complication, which is just turns out not really to be worth the trouble, because we can get what we want without that. So I'm just going to eliminate that and use this. But in case you were wondering where that comes from, that's what it means. In addition to that, we can read in data from the internet, which is what we will commonly do in this class because that's the easiest way for me to share the same data set with you all. So this is what we were looking at here a second ago, this link right here. To get that into R, you just, instead of specifying the file name on your local machine, within those quotes, you specify the HTTP link, the URL instead. And it's the same thing. I'm going to load it into VOT data too, and that should work, and it did. But it's going to be the same data, just loaded in a totally different fashion. Yeah, so, okay, now we have the data in the R console, so we can play around with it. I'm going to give you a little tip here. This could very well make your life easier. VOT data, actually, yeah, like, I'm going to skip ahead here. Like, summary VOT data. So, we've seen this summary command before with like our ppod data. And when we have it, when you'd use that for a data frame, which has multiple columns full of data in it, then it gives you a summary in different fashions for the variables in value, the variable values that you see in those columns. These are pretty boring on the whole because the only real data point that we care about is this VOT data in the last column. And this gives me that 5-number summary and also the mean value that we've looked at before for VOT, and we can kind of make sense of what's going on here. But in addition to that, we have a number of variables which aren't quantitative. They're not numeric in the same way. Instead, they're kind of varying in terms of like place of articulation or vowel or so on and so forth. So they're like different strings that we might see. And this just tells you that, you know, the data set is balanced. Like we have even numbers of like 3 different places of articulation or all the vowels or so on and so forth. But the point I want to make here is that we're going to, at some point, want to be able to refer to these specific variables in the data frame. Like if tell me something about the word. And again, jumping ahead of myself here, so I can go give me a summary of VOT data of just the VOT variable itself, and the notation I use for that is say this is the data frame name, and then I have this $, which represents what follows as a variable name, and then the variable name itself is VOT. So if I do that, it'll spit out. It should spit out the 5-number summary I see here, along with the relevant mean. And it just does it in a sort of horizontal format, but it's the exact same information, right? What I can't do, even though it seems like it's intuitive that I should be able to do, is to just say, give me a summary of VOT, give me a summary of that variable. If I do that, it just says that I can't find it. So the reason I'm saying use this attach VOT data command here is that it will enable you to do that. Like that. So if I go back to the summary VOT command, then I get that information easily. So this is going to save you a little bit of trouble in some cases where you don't have to constantly be like repeating the data frame name and then also this sort of variable notation of the $. You can just do it a lot more simply thinking about the variable that you actually care about. Yeah, and the one caveat to that is that if you load multiple data frames into your R console, then you know, sometimes you might have the same variable names for different data frames and it can get confusing. So I might advise against doing that. It works better if you're just playing around with one data frame at a time. But if you do play around with one data frame at a time, it will make your life a little bit easier. All right, so enough of that. I can also show you there's a names command,
which just shows you the names of the variables or the column names in your data frame for whatever that's worth. Summary, already took a look at that. Yep, and already looked at summary VOT as well. Navigation. So, right. This is probably going to be more information than you'll actually find to be useful, but just in case, I'm going to tell it to you because somewhere down the line you might be able to use it. So when playing around with R commands, each cell on the data frame can be specified by its row and column coordinates in that order. So bracket 6, 2 bracket refers to the 6th row and the 2nd column of the data frame, which should be, so this is going to be counted as row 1, 2, 3, 4, 5, 6, and then the 2nd column will be beer. So if I put VOT data 6, 2, if I put that command in my R console, it gives me beer, free beer. Anyways, it's right there. And then it goes through and tells me like all the different words that are in that column as well, which is not really as useful, but I can specify what's in that particular cell this way. If you want to, say, just look at the entire first column of the data frame, i.e. the first variable in the table, like that column, you can get it with this command, where you leave the row part of the command blank and just have bracket blank, comma 1. And then it gives me all the names for whatever that's worth as well, in order. And I'm going to mention as well, I kind of glossed over this quickly when I was walking you through the first command. This is considered the first row in the data frame. So if you say this is my header row, header equals T when you read in the data, this is going to wind up being the first row, and then everything else moves up sort of accordingly down here. So we have 421 rows with stuff in it, with stuff in them in the Excel spreadsheet, but that winds up being 420 rows when you actually load it into R. Yeah, and I think, yeah, I mean, like Sue is 417 here, so on and so forth. This is 418, 419, 420, right? You can do the opposite. You can look at just a particular row, which is actually probably going to be more meaningful in most cases, by leaving the column part of this bracket notation blank. Then you get just this, particular observation for Zilka's VOT. You can also grab a range of rows with this colon notation. So for this one, I just like, give me row number 3. This one will give you 3 rows from 5 through 7 inclusive, and it'll look like that, which is kind of nice. You can also grab arranged columns. Don't know entirely why you would, but just in case you want to, you leave the row part of it blank again and just use the colon notation for the column range. And then you get those 5 columns. And there's a lot of them, right? So yeah, it does go down to 420. That's a nice way to see that. That 420 is not meant to mean anything, just in case you're wondering. We already got beer. We're already set as far as mood enhancing materials are concerned. So anyways, by using the $sign operator, I've shown you this before, but you can also specify the variable or column that you want to look at without using the bracket notation. And then in almost all cases, this is how I'm going to do it from here on forward. So if I want to just look at like the VOT by itself, I could use that notation. This is the data frame. This says what follows is a variable, and this is the variable name. Darn it. This is the variable name itself, VOT. And since I've used that attach command, I think I can just type VOT and get the same information, right? It goes by quick, but there's the VOT, and it's giving me the exact same variable values. By the way, give me a second. If you want to sort of loop or review your commands that you've used before, you can use the up arrow on your keyboard. And I'm sorry you can't see that. Maybe I should do it like this. I'm going to go down first. Use the up arrow on your keyboard, and it'll sort of scroll back through all the different commands you've used. The tricky part is, so you can go like, let's go here. I want 3 through 6 instead. And then you can kind of just like, maybe I should be doing it this way. Yeah, so I already changed that 6. And so now if I hit that up arrow again, it doesn't keep working. But if I go to the end of the row, end of that command, then I can go back to sort of tweaking things or looking back through the history. yeah, where was I? Like 3 through 7. Yeah. So what I did there was, if I can do this like this, I've never tried this before, but yeah, 3 through 6, please. And then go back to the end of the command, hit return, and then I get just 3 through 6. Yeah, you'll figure that out eventually, but up and down help you out a lot in your commands here, just so you know, as you're getting familiar with the system. Yeah, a couple more fun things you can do. You can order data. So I'm going to order the rows in this particular case. So in my brackets, where if I left this blank, actually maybe I'll leave this blank. So again, if I leave the rows blank there, that just gives me the data for columns 1 through 7 as they're in the data frame itself. But let's say I go back to that command using the up arrow very sophisticatedly, and go back to that blank spot in the row section, and I'm going to copy this command in there. So this just says order everything by the value of VOT in my data frame. And what that does is gives you an automatic sort according to the values of this final column in the data frame. And then it sorts everything else, columns 1 through 7, by that value. So as we see, it goes from smallest to largest here. So the very negative numbers wind up being at the beginning. The lowest one is negative 231. And the highest one is 235. It's almost balanced on either side. But this is in order for column number 7. And you can actually do this the opposite way, which is cool. And actually, I'll double check. Pretty sure you can do this now that we've attached this variable name. Just order it by VOT without including that data frame stuff. And yeah, that works. And I'll do it this way as well. I'm going to say, give me a reverse order of VOT. And I just have to put parentheses around all of order VOT, and it should show it to me in the exact opposite order. Nice and simple like that. And voila, there you go. Okay, so that's just navigating your way around the data frame. This is maybe, in many cases, will be a more useful command. It's the subset command. So let's say you only wanted to look at the data for one speaker in the data frame, and there's a variety of different ways to do that, but this is a straightforward one, which is to use this subset command. Okay, so subset, and then what it's going to operate on is going to be within these parentheses again. So it's going to operate on this VOT data frame, and what I want it to do is just pick out the speaker Zilka. I want her data points only, her observations only. So this will pick out only those data points, and it's going to pipe that information into this new data frame called Zilka itself. So I can hit return there, and nothing will appear to have happened. But I'll show you a little trick here. If I type ls and then leave parentheses blank after it, it'll tell me what sorts of data frames exist in the system, or what sort of structures exist in the system. And now if I have Zilka, it just gives me this subsetted data frame that has only those observations in it for that particular speaker. And actually, as long as we're here, in case you do want some obvious action, you can leave out that sort of pipe it into a new data frame part of that command and just say, give me that subset, and it'll give me that exact same information. It's just not going to be as useful because now it's here on the screen and I can't really use it. But if it's in the Zilka data frame, now I can play around with that. So I could say, like order Zilka VOT or something like that. Maybe this will work. Yeah, it does. This is, yeah, that didn't work at all. I shouldn't have done that. Never mind. It should be a lot more like that command we were using a second ago. So we'll just say Zilka VOT. This is what I was hoping to demonstrate. And yeah, and so this orders like Zilka's like observations in terms of her VOT. Okay, yeah, so if it's in a data frame, I can play around with it. The other part of this that's important is to note the syntax of how this works. So Zilka is a name in one of these alphabetic variables, which are most of the columns in this particular data frame. So to refer to Zilka specifically, I have to use this notation. So I have to say, give me speaker, that variable name here,
go back to the data frame itself. So I'm looking at this variable, and then equals, equals, because I want to just match which rows have this speaker value. And then because it's alphabetic, I put the actual name in quotes. All right, so you have to do all those things, otherwise it's not going to work. R is picky that way, like every single other programming language. So unfortunately, you have to get used to that if you don't normally worry about fine-grained details like that. I don't know what to tell you, but that's going to be the way it works the rest of the way. However, the way it works for numeric variables is you don't put the quotes around the specific value you're interested in. So let's try to create a data frame here that only takes the observations which have VOTs of 100 milliseconds specifically. So I'm grabbing data out of this data frame again. I'm looking at this variable, and I'm only going to pick out the observations that have exactly 100 milliseconds VOT. I'll pipe it into this new data frame, VOT 100. And what does that look like? It gives me 3 observations from a couple of different speakers. That's it. But they all have 100 milliseconds of VOT exactly. Yeah, you can also do a couple other things. You can combine logical operations. So hopefully somewhere down the line you took logic, because it'll make your life easier and you'll, in theory, think more clearly if you do. But we can save the ads for that for the philosophy department. But the relevance it has for like using a programming language like R is that you have to think very rigidly, I guess, in terms of how you're combining notations here. So what we're going to do here is combine the notations for grabbing a specific alphabetic value for a variable. Namely, we're going to grab the speaker Zilka. We're also going to grab a specific set of numeric observations, such that we're only going to look at the observations here where VOT is greater than 100. So we're going to combine that with this operator, the ampersand, and it'll give me only those observations which are produced by Zilka and have 100 milliseconds or greater VOT. And actually, now that we're here, this little fun fact of trivia that I learned is that this symbol, which is kind of a weirdo, it kind of looks like a dude reclining or something like that. It's actually, the word for and in Latin is et, which is spelled et. And if you look at this in the right fashion, you can kind of see that it's actually an E and a T like glommed together. Like on the left-hand side, the dude is like the E part, and then this little cross here where it looks like his hands are going across his legs, that's the T part. There you go. Anyways, the command gives you that. So this is all the Zilka productions with 100 milliseconds or more of VOT. Yeah. I also want to show you how to put 2 data frames together. We'll grab Yuna's data. So this is just all the productions by Yuna. We've already got all of Zilka's here. We can put them together and say, give me 2 speakers, Zilka and Yuna together for whatever reason. The command for that is the rbind command right here. And just put the data frames you want to combine into the parentheses for rbind. Rbind means row bind, so basically add, once you're done looking at the first data frame, just add another set of rows to it, namely the Yuna rows. So this should give me the Zilka rows and then the Yuna rows, and it does. So that's pretty easy to get that to work. I'm not going to walk you through it, but there's a similar command called cbind, which binds columns together. It just kind of is a little more difficult to get to work in the way you want to. Yeah, so this shouldn't be Zilka. This should be 2 speakers, but whatever. Yeah, and right, actually all these commands are kind of off. Sorry, I'll have to fix that before the fall. Whoops. Let's say we want to look at like the average VOT value for the 2 speakers. We get that. If we want to look at it for just Yuna, we get, something like this. Yeah. What you can't do though is if VOT is already like assigned to like the whole data frame that we began with, you can't expect to type in this command and have it refer to sort of what you were just focusing on, whether it was Yuna's VOT or the 2 speakers VOT, so on and so forth. Just a reminder, this tells you what data frames are in the system, this ls command. And we've got a lot of stuff in there, most of which is kind of
not really meaningful, but hopefully it helps you understand how to get this to work a little bit better. All right, so I've already walked you through that. The last thing that we should talk about is saving your work. So there's kind of two elements that we have to think about for this, and then I'll say goodbye. So the work that you can save in R involves two separate things. It involves the workspace and the console. So the workspace is this information here that you see when you type in ls parentheses. So it's basically all the data frame information that's been assigned to memory in the system in some fashion. So usually if you're like working through your data and getting some sort of like efficient like formatting for your information that means something to you, you want to be able to save that workspace. And so how you save that works differently on a Mac versus a PC. On a Mac, we go to the workspace, and we can say save workspace file. So workspace is just the menu option, and then save workspace file is down here. And I will just say workspace example is how I will call it. And so it's there. And you can actually, I don't really need to, but if I go to load workspace file, it will go to the exact same working directory that I've been playing around with up to this point, and I see my workspace right there. It's very small, it's only 3 kilobytes because this is not that much information, but I don't need to load it in again because I already have it in there. So I will show you a series of commands you can use just to sort of confirm that that actually works. So I'm going to say show workspace, and that's the exact same thing as using this ls command, but this is working through the menu now. And I want to save the workspace file. I'll save it as something different here. I'll say workspace example 2, just so we don't lose that first one. And now I'm going to clear the workspace, and that will remove that information. And actually, that's such a dramatic move to take that it's going to say, wait, do you really want to do that? And it's like, yes, I'm teaching a class. It's all academic. So now if I show the workspace, it will show me nothing. So it just has this, like, I guess, sort of default like placeholder called character 0. Actually, what happens if I type in character 0? It gives me character 0. Yeah. Is recursively meaningless, I guess. Anyways, what I want to do is get that information back, because really I did not want to clear my workspace. That was horrible. Why did I do that? So I'm just going to load it up this way by highlighting and opening, and now I want to show the workspace again, and I will have all that information back in there. Yay. So save early, save often. Never trust your computer if you don't have to. Yeah, there's also a workspace browser interface, which is kind of cool. This shows you like what kinds of data frames you have in the system, and also can like give you some basic information about it as well. I don't use it that often, but it looks pretty cool to check out. And the last thing I will mention is the console. So the console is just a series of commands and outputs that appear in the R window, i.e. everything you see in this window here. And this is something I want you to know how to save, because whenever you submit a homework, I'm going to want to see your entire console. It may or may not be useful for you to send me your workspace for a homework problem. That's optional, but what is not optional is for you to choose not to send me your R console. You have to send me your R consoles for homeworks, because when you mess something up, it is extremely helpful for me to be able to go back through your series of commands and try to figure out what you did. And I know what this means because I've seen this many times, but it means that I'm going to be able to see like your thought process where you're trying to figure something out and where you like screw up like 25 times and then finally get it. So guess what? I'm not editing these videos either when I make a mistake, because we're all in the same boat together. It takes a while to learn something. Don't be ashamed if it takes a while to like figure out how to do something. It is much more useful for me to be able to see your mistakes than it is for me to be able to see just like a nice finished product at the end, because I'm trying to help you figure out what's going on when you're just learning how to do it. Okay, so give me everything. I'm going to snoop in your mind to figure out what it's doing with stats. I'm not going to look at any other parts of your mind. Don't worry about it. But anyways, to do that, you need to save the console. And to save it, it's kind of what you would save by default. So you go to File and just Save As on a Mac. And I'm just going to say
So R command video example, and that's going to be a text file. Yeah, so apparently on a PC you save it by going to File and then Save History, and that just saves like everything that you've done in R up until now. So that actually gives you probably more information than you really need, but do it anyway because otherwise you can't save it. Anyways, I can go on my hard drive now and take a look, and it's not going to be as pretty as what you're seeing in the R console, which is not actually that super pretty to begin with anyways. I think it's in here, right? So yeah, I can double click on this and it should open up in my text editor. Yeah, and this might be hard to see in the video, so I'll try to make it a little bit bigger. Can I make it bigger? Zoom in. Yeah. So it's a little bit bigger, but this is everything that I just did in this video, right? Including the output of the commands, which is a lot. Yeah, but that's how you save that part of your work. So there's the workspace part of it, and there's a console part of it, and the console part is the really important part. Yeah, and that's all I'm going to say for now. I might have a little bit more to say about basic logistical commands for R in the next video or two, but I'll stop for now because it's long enough. And like I said, I'm trying to be efficient, even though there's a lot to learn. All right, so I think next time we'll talk a little bit about linear transformations in lecture. So I'll look forward to seeing you all then, if not sooner.